You are welcome back to this channel. So we are still on mathematical induction. So today we want to prove by mathematical induction that if n is a positive integer, then 5 raised to the power of 2n plus 3n minus 1 is a multiple of 9. So what this is saying is that if you input any positive integer in this expression, the answer gotten will always be multiple of 9. That is, 9 will divide it easily without any remainder. So we want to check if that is true. So by mathematical induction, the first thing is that we have to test for n is equal to 1, if that is true. So test for n is equal to 1. So that means anywhere I see n, I'll be putting 1 there. Multiply by 1 minus 1. And that gives me 5 raised to power 2 plus 3 multiplied by 1, 3 minus 1. And that is what? 25 plus 3 minus 1, which is what? 27. And 27 is what? Is a multiple of 9. You like, you can test for n is equal to 2, but because of this video, we are not doing that. So the next thing is that assume n is equal to k is true. So you want to check if you take any number, is it going to be true? So what this means is that anywhere I see n, I'm putting k. So 5 raised to the power 2, then n changes to k plus 3n, so it will be 3k minus 1. Now, you know we are assuming. So we want to assume that everything here is a multiple of 9. So that means we have to equate it to be equal to 9p or 9m or 9a, anything. So, and I told you that if you multiply 9 by any number or any alphabet, it is always a multiple of 9. So from here, so I want to make 5 raised to power 2k to be the subject of the formula. So I have 9p minus 3k, then plus 1. So I'm keeping this one because I will use it later. So we are done with the assumption. So the next thing is that we want to prove that the next number after k, which will be k plus 1, will be true if n is equal to k is true. So prove that n is equal to k plus 1 is true. We have to go through this. So anywhere I see n, from these 5 raised to power 2n plus, to prove that n is equal to k plus 1 is true. From 5 raised to power 2n plus 3n minus 1. Anywhere I see n there, I'm putting k plus 1. So I have 5 raised to power 2 into bracket k plus 1 plus 3 into bracket k plus 1, then minus 1. So let's simplify this. So I have 5 raised to the power of 2 multiplied by k, 2k, plus 2 multiplied by 1, 2, then plus 3 multiplied by k, 3k, plus 3 multiplied by 1, 3, minus 1. So, and according to law of indices, if I have a raised to the power of m plus n, you know, it's the same thing as saying a raised to the power of m, then multiply by a raised to the power of n. So this is the same thing if I have 5 raised to the power of 2k plus 2. It is what? 5 raised to the power of 2k multiplied by 5 raised to the power of 2. So now, this becomes 5 raised to the power of 2 multiplied by 5 raised to the power of 2k. So plus 3k plus 2. 3 minus 1, 2. Recall from equation 1 that 5 raised to the power 2 is what? 9p minus 3k plus 1. So anywhere I see 5 raised to the power of 2k, I'm going to put 9p minus 3k plus 1 there. So from equation 1, 5 raised to the power 2k is equal to 9p minus 3k plus 1. So I want to input it here. So I have 5 raised to the power 2 is 25. So I have 25 into bracket. 5 raised to the power 2k, I will put 9p minus 3k plus 1 there. Then I have plus 3k, then plus 2. So now let's simplify this one. 25 times 9p, that is 225p, minus 25 times 3, that is minus 75k. 25 multiplied by 1, that is plus 25, then plus 3k plus 2. So I have 225p, then minus 7k plus 3k, that is minus 72k, plus 25 plus 2, that is plus 27. So from here, let's check. Are they all multiples of 9? 225, let's divide it by 9. What is that? That is 25. That means it's a multiple of 9. Then, so let's factorize 9 out. So here I have 25p. If I divide 72 by 9, that is 8. So I have minus 8k plus 27 divided by 9, that is 3. So from here, we can see that this is a multiple of 9. So hence, when n is equal to k is true, then n is equal to k plus 1 is also true. So therefore, 5 raised to the power 2n plus 3n minus 1 is a multiple of 9 for any positive integer. So that is how to find that. So you can go through it. The first thing is that you have to test for n is equal to 1. So if you like, test for n is equal to 2. So the next thing after that is to assume your n is equal to k is true. Then prove that n is equal to k plus 1 is true. So by proving, then you arrive at here. Till I see you again. Bye bye.